Chapter 5, Product Design and Rapid Prototyping. This chapter introduces concept design stage of design cycle of product. The subjectivity in the concept design is explained in objective manner for design of innovative product. The process of rapid prototyping is explained in the chapter, which makes it possible to get the physical model of the innovative product directly from computer model without human intervention and tools. Learning objectives. Number 1. Learners will be able to design innovative products using the trees technique. Number 2. Learners will be able to understand the rapid prototyping process as a new process of prototype manufacturing. Number 3. Learners will be able to link innovative product development with the rapid prototyping. Para 5.1. Need for innovative product. Para 5.1.1. Turbulence in the technical world because of stiff competition. The advent of computers and liberalization policy led to turbulence in the industries and the technical world in general. The word turbulence signifies mixing of lot many issues, namely technical, political, financial, and hence indicating a not smooth flow of activities in the industrial sector. Competition in any sector, including engineering, is always looked at for progress. It is true that because of competition, every element tries to excel. But think of the situation wherein no element wants to participate as there is stiff competition. In developing countries, industries are finding it difficult to survive in stiff competition worldwide. The developed countries in general are also facing the problem of recession. The time has come to look into this matter seriously so that there will be a smooth ride over all the problems created to date. The basic philosophy of designing the product and then only focusing on its manufacturing in mass quantity and marketing, that is, neglecting the improvements in the design of product, needs revamping. The frequent change in the design of product is the key to success. This may be referred to as innovation in the product. Manufacturing and marketing of new products pose a challenge to the industry in the developing world. It is therefore necessary to gear up for this hurricane task to set a smooth path to the future. Incredible shrinking product life cycle. Constraint in manufacturing always limits the building the concept of design of the innovative product. It may also be noted that the product life cycle, which comprises many stages, namely design, manufacturing, marketing, and retire, is incredibly shrinking because of the CAD/CAM and computer database management system. The product goes out of fashion within no time, and the need for another is felt. It is therefore equally important to focus on the design and development of new products, even if the need for it is not thought. As in Olympics, the player breaks his record. It is of utmost importance for engineers in the industrial sector to compete with their existing successful product and aim for a newer and innovative product. Manufacturing science is supported by the use of computers and many more modern techniques like additive manufacturing. Because of the least human intervention, accuracy in product manufacturing is high, and the product cycle is shrinking incredibly. The example which will be worth mentioning here is, it took decades for the rotary phone to evolve to a push button. Today, a smartphone will get obsolete in 12 months. Refer figure 5.1. Human comfort playing the dominant role. The human being always strives for comfort. The movement in animals is for getting the prey to meet the hunger and to show superiority over the others. As human being is gifted with the power of the mind by nature, the human being has managed to meet his daily needs very quickly. Thus, in contrast to other animals, a human being always strives for more and more comfort. It is therefore essential to design a product that gives more pleasure to a human being. It is proper to mention here the example of refrigerator as a household product. The freeze has gone through many stages in product development, from auto defrost to frost free, to give more comfort to a human being. This is vicious cycle, and the need for innovative products will always be felt. It is observed and seen that the quality of human beings to strive for comfort leads to creative product development and hence industrial progress of the nation. Para 5.2 Design Cycle. In industry, The design of the product follows the manufacturing of products, and finally, the product is marketed or sold. Refer figure 5.2. The three stages are shown in the cycle, indicating the design of the product that needs to be changed often to stand the stiff competition in the world. Generally, marketing of the product is not essential to engineer, as he or she thinks that the best quality product designed and manufactured by him or her is readily sellable. This is a misnomer, as it is difficult to predict the taste of the customer. In the design stage itself, the need analysis for the product should be carried out. Right in the first stage, that is design of the product, customer should be involved so that the design will start with robust backing and the resources will not be wasted. Figure 5.3 shows the design cycle, which explains the various stages, including production. Generally, the cycle shown in figure 5.3 is called the ideal design cycle, as at every stage of the design cycle, that is concept design, engineering design, and detailed design, is linked with prototype manufacturing. This can be viewed as getting the prototype or physical model in every stage of design until the designer is satisfied. The assistance of computers in design helps to modify the design at every stage, but getting the physical model requires resources. This is a big hurdle for the feasibility of the cycle, and hence the cycle shown in figure 5.3 is labeled as an ideal design cycle. The conventional manufacturing process puts more constraint on getting the physical model when linked with the design stage. The design department of most of the industries from developing countries are facing the problem of entering into the domain of developing an innovative product, as the feasibility of ideal design cycle is not achievable. The design cycle indirectly shows the way to create an innovative product where the design of the product is free from manufacturing constraints. If the prototype is possible without human intervention and tooling, then at every stage of design for the changes made, a physical model can be obtained. The process seems to be more complicated, but with the help of new technology like rapid prototyping, RP, it is feasible. Figure 5.4 explains the RP process, which is discussed in detail in para 5.12. Para 5.3, Innovative Product. To define innovation in the product is most difficult. The innovation means satisfying the need of customer and also maintaining the uniqueness in the product which make it sellable. Generally, the geometrical form, material of the product and ambience play the dominant role in the uniqueness of the product. The innovation in the existing product is more straightforward than innovation in the product which is not existing or is developed from scratch. Product design in both cases is only possible by using two techniques, namely trees and bionics. These techniques do not spell out the logical steps to get innovative product, but they are useful in guiding the design engineers for systematic brainstorming, which kindles the innovation. Rapid prototyping also plays a prominent role in the innovation of product, as a computer model of the product is possible to see as the physical form of the product and hence leads to more effective brainstorming. In the design cycle, product innovation means concept design. The concept of the product which can be manufactured and sellable is the most critical stage. The sellability of the product means the cost of the product, which is justified considering the quality of the product. It is sometimes necessary to get the new manufacturing process of existing product with less price compared to the existing method of manufacturing, and thus innovation in the product is justified. For innovation, the design engineers may not always require to look into the new product from scratch, but can also think of developing the unique process of manufacturing the existing product, which is cost effective and environment friendly in the concept design stage. The deliverables at the end is a satisfaction to the customer. Para 5.4, Software Development and Software Operation. The software plays a dominant role in the product design and manufacturing. It is essential to understand the role of engineers in software. The operation of ready-made software, that is getting the output by feeding input and treating software as a black box by using simple command, should not require any skills. Any engineering software which can be operated by a person who is not an engineer is most sellable. This means no need for experts for the operation of software and getting the task done. In AutoCAD software, drawing the circle using the command is the simplest, and even higher secondary students can operate the software to get the drawing on the computer. The development of the software, which is simple to operate, is most difficult. An engineer must get trained in software development. Thus, engineer needs to know how to develop the algorithm to draw the circle on the computer. To develop this software, every engineer who is interested in innovative product design and development should be familiar with a higher programming language. The software, which is developed as a user-friendly, can be operated at ease for product innovation. Para 5.5 Manufacturing of Product. The design leads to manufacturing and finally marketing. Unless the product is marketed or sold, there is no deliverable from the industry. The manufacturing of the product as per the design, which involves the design of the innovative product, plays a significant role in the industry. The success in the manufacturing of the product guarantees the sellability of the product, hence profit to the industry. The innovative product may not be designed considering the conventional process of manufacturing. The million-dollar question is whether it is possible to manufacture the product which is designed without considering the traditional process of manufacturing. The innovative product is viable to design if rapid prototyping is used. The conventional manufacturing processes may not be suitable for innovative products, but they are useful for mass production. The term mass production needs to be seen from the global market point of view. Thus, rapid prototyping is necessary for innovation and conventional manufacturing is required for mass production. The manufacturing of innovative products, which is the need of the industry all over the world, is possible by clubbing both, that is, rapid prototyping and conventional manufacturing processes like machining, casting, etc., which can be called as rapid prototyping assisted manufacturing. Manufacturing means traditional methods of manufacturing. For example, in RP-assisted casting, rapid prototyping is used for pattern making and thus pattern making is more comfortable to perform, which helps in mass production using casting. Refer figure 5.5. Para 5.6 Marketing the product. It must be noted that sales and marketing are different. The product which is marketed easily is also sellable. Thus, addressing the sellability issue may be taken as selling the product. Therefore, we shall discuss only the sellability issue. The engineer never looks in this domain seriously and always feels that design and manufacturing are essential in product development. If the product is not sold in the market despite using the best practices of marketing, then resources involved in the product development goes waste. It is of utmost importance that engineers should focus attention on design and development, keeping the need of the customer in mind. One of the most essential factors for the sellability of the product is its cost. The less price and best quality are the key phrases for the sellability of the product. This phrase represents a contradiction. To get the best quality in the product, the cost may rise. The quality of the product also means the product should be environment friendly. The design and manufacturing engineer should always think of getting the best balance between quality and cost right from the beginning. For the design engineer, simplicity in form, materials of the product play a dominant role. Most of the time, design engineers only think from technical aspect to get the quality product but forgets about the cost or vice versa. Developing the costly innovative product having a high quality is desirable. So also of developing innovative product having less price considering the affordability of the customers. Standing in the middle of the road is dangerous. The constraint from manufacturing also affects the whole design process and hence finally sellability. With the introduction of rapid prototyping, the design engineer is free to think, that is without the worry of manufacturing process of the product and hence ready for designing the sellable part. Another critical issue is about manufacturing the part with new innovative process so that product cost will be less and quality at its best. Most of the time, attention is paid to the manufacturing process based on the literature and available practices without considering the damage to the environment. The typical example is of foundry practices. The preparation of mold in sand casting is carried out using the binder for the sand. After pouring the molten metal in the mold, the gases are released as a result of the burning of the binder. The released gases pollute the environment, which needs to be monitored appropriately. Else, the product may be least in cost, but the quality of the product is poor as the manufacturing affects the environment severely. It is easier for an engineer to focus more on design and manufacturing so that product is readily sellable and fewer resources on the marketing of the product will be required, which in turn makes the product less costly. The more emphasis on the marketing of the product is beyond the scope of this book, but design and manufacturing engineer should look at the marketing of the product seriously. At this stage, attention of the reader is again brought to figure 5.2, which is shown below as figure 5.6, where the cycle repeats only after getting the feedback from marketing. Para 5.7 Concept Design. Para 5.7.1 Ideality Innovation Redefined. The subtitle of the Para 5.7.1 involves the word redefined because innovation is already discussed in Para 5.1. The concept of innovation is more subjective and the need to define the innovation objectively is felt as engineers prefer objectivity. To define innovation in the mathematical term is challenging. The first and foremost is to identify two approaches in innovation. The first approach is to innovate the product which is existing, like changes in the design of automobile gear to get it more productive in operation. The second approach is to design the product which does not exist, like the ambulance which will have a feature to overcome the hurdle of traffic jam. Refer figure 5.7 and figure 5.8. The term ideality can easily explain the innovation in the existing product. Ideality is defined as the ratio of design objective to design constraints. It can also be described in more easy term as the ratio of summation of useful function to the summation of harmful function. The ideality of the product can be expressed in numerical figures and the design engineer is free to use the term in ideality as per his convenience. The ideality of the best product will be infinity as there are no design constraints for the design of the product, or in other terms, no harm. The ideality of the worst product is zero when there is no design objective, or in other words, no use. Best product, ideality is infinity. Worst product, ideality is zero. Once the ideality of the existing product is defined by design engineer in numerical form, then innovation in the same product is to increase the ideality of the product. Thus, approach to improve the ideality of the product is the innovation in the existing product. The design engineer should always think of improvement in the ideality of the product, which will be termed as innovation. Para 5.7.2 Paths to improve ideality. The design engineer should think of improvement in ideality for which continuous attention on the product functionality and brainstorming is necessary. The design engineer may use the following paths to improve the ideality, but he or she should not be constrained to think only on those paths. Number 1, exclude auxiliary function. Number 2, exclude elements. Number 3, identify self-service. Number 4, replace elements, parts or total system, that is simulation. Number 5, change principle of operation. And number 6, utilize resources. The paths mentioned are only guidelines for improvements in ideality. These are not laws or rules. The innovation in the existing product is linked to the sellability of the product. The self-explanatory figure 5.9 explains in short the paths to improve the ideality. Para 5.8 Brainstorming and innovation. If the product is existing, then innovation in the said product is mainly to solve issues related to problems in manufacturing or marketing, customer satisfaction for sellability. The innovation requires mostly brainstorming and dedicated effort, namely thinking continuously, that is 24/7 about the issue. Though the techniques of brainstorming are available, getting the right solution to the problem of an existing product, that is innovation in the product, is most difficult through brainstorming. Engineers always strive for some techniques or methodology which can streamline the discussion during the brainstorming and hence striking the right solution. The right solution means finally accepting the product by customer, which is difficult to predict. Keeping the cost low, sacrificing the quality, is considered by some industries as the best way for customer satisfaction. Still, in engineering science, such products are accepted, but they are short-lived. To get effective brainstorming, thinking plays the dominant role. But if the thinking is rightly guided, the chances of getting the success of the product in first go increases. Here the word success means the sellability of the product and product remains in the market for a longer duration. The critical issue is to know about well-guided thinking for effective brainstorming. The two techniques, namely bionics and trees, are useful in this context. It may please be noted that guided thought does not mean that there is a constraint on design engineer. The guided thinking means getting conscious about one solution by all members in the brainstorming so that the next stages in design cycle, namely engineering design and detailed design, follow. Finally, production of the innovative product starts. Bionics gives more emphasis on nature and trees uses tools to get innovation in the product. The engineer likes these two techniques as it brings objectivity in the product design, which is more subjective. It may be referred to as objectivity in subjectivity. Para 5.9 Bionics. Bionics refers to imitating nature and getting inspiration from nature. Simply looking at nature, that is flora and fauna, it is possible to get the concept that helps in design and design modification. If we look at nature from the engineering perspective, we get disappointed as the geometrical shape, form of the product of nature are not easily reproducible, that is manufactured in engineering. This is appreciated when we look at flora and fauna. The product design engineer either designs the part which does not exist, that is designing from scratch, or modify the design of the existing product. We call it innovation if he or she succeeds in both the cases. If the product is to be designed from scratch, then it should not go out of the fashion in a short time. If the modification in the design of the existing product is to be carried out, then permanent solution to the problem for which the design to modify should be sought. Bionics is the best solution for all such type of design modification. It may please be noted that Bionics plays a role in the only concept design stage. It is difficult to frame the flowchart or algorithm which can be used as a study of bionics. The thumb rule is to look at flora if the object is to be designed is moving and look at fauna if the object is to be designed as stationary. The key to getting the solution using bionics is always to observe nature. Figure 5.10 and 5.11 explain about the use of bionics in designing the product which is existing and the product which does not exist. In short, Figure 5.10 shows how the shape of the beak of kingfisher is used to modify the shape of the engine of the bullet train to solve the problem of sonic boom created while the bullet train coming out of the tunnel. Figure 5.11 shows the need for an ambulance which can overcome the problem of traffic jams on the road and possible solution by taking inspiration from the kangaroo leaping. Many such examples can be quoted, but it must not be forgotten that thinking plays a dominant role in innovative product design. A ready-made solution is not available. The bionics is the niche area and tremendous opportunity for research are available. Para 5.10 Trees. The Altshuler theory or trees also can be used for effective brainstorming in the product design. The tools of trees are defined which help in well-guided route for thinking. The tools for trees are Number 1, contradiction matrix. Number 2, substance field analysis. Number 3, scientific effects. Number 4, ideality. And number 5, separation principles. The ideality tool is already explained. Out of the remaining 4 tools, the contradiction matrix and substance field analysis are more effective. Para 5.10.1 Contradiction matrix. The technique of contradiction matrix uses contradiction, which is useful in developing the solution. Some of the examples are more power and less maintenance. For example, in military vehicle. More reliability and less energy consumption. For example, in case of air conditioned system. Small car and big car in case of car design. More power and less weight in case of aircraft design. The design objectives are contradicting each other. For example, in the case of aircraft design, more power is required but the weight should be less. In contradiction matrix, columns represent characteristics of design objectives that are getting worse and rows represent characteristics of design objectives that are to be improved. The elements of the matrix contain design principles to be used for the idea or concept of innovative products. The skeleton of contradiction matrix is shown in figure 5.12. 40 innovative principles are used in the contradiction matrix. The reader may surf the net for detailed information about 40 innovative principles. Contradiction matrix is very useful in developing the concept of design of the product which is existing and also for the product which does not exist. It should be noted that every product has at least two design objectives that are contradicting each other. If the product does not exist, then find out the design principle which suit its contradicting design objectives. The design principles help in effective brainstorming for developing the concept. The designing the means or product for commuting to avoid the traffic jam. The two contradicting design objectives, namely less weight and more speed, can be selected in contradiction matrix. Based on these contradiction design objectives, design principles 1, 2, 3, 4 as shown in contradiction matrix can be used to initiate the brainstorming, which will be neatly guided. The use of more contradicting design objectives can bring more innovative principles in the discussion, but the creative principles having more frequency of operation should dominate the brainstorming. The use of bionics along with the contradiction matrix will be appreciated, as the concept design stage involves only the concept of the product without due consideration on engineering and detailed design. The contradiction matrix and bionics are very useful. Let us see how the example of flying ambulance used in bionics can be handled using the contradiction matrix. Design objectives and design principles are shown in table 5.1. Tables 5.1 and 5.2 indicate, and the illustrative example, that design principles number 10 is more effective in developing the concept of the product. As mentioned in the bionics section, an example of kangaroo and design principles as selected from the contradiction matrix will guide the design engineers in brainstorming to develop the concept of the product. The thinking finally plays the dominant role, but the orientation of thinking using the method of contradiction matrix and bionics needs special mention. Para 5.10.2 Substance Field Analysis, SE Field Analysis. This tool of trees is simple and effective in developing the concept of design of the product. The basic methodology states that two substances and fields are necessary and sufficient to define the working of technical system. The desired function is output from the substance S1 caused by the another substance S2 with the help of energy, that is field. Refer figure 5.13. Any product or technical system which is existing can be viewed considering S1, S2 and field. The example of rock and hammer are shown in self-explanatory figure 5.14, which helps to understand the substance field analysis. It is clear from the methodology, change in the energy field also indicates an improvement in the product. The best example is the steam engine to a diesel engine and then to an electric engine. To improve the product or technical system, following steps are suggested. Introduce the new field. Change S2 from macro level to micro level. Change S2 to a porous or capillary material. Introduce a new substance. Self-explanatory figure from 5.15 to 5.17 explains the improvement in the product. The steps to be followed in SE field analysis to develop the product are shown in figure 5.18, where 76 standard solutions are used. Refer the link for more information about 76 standard solutions. Para 5.10.3 Scientific Effects. Innovative product design, IPD engineers must be aware of all the latest development in the scientific world. There are discoveries or scientific innovation everywhere, as proved by the Nobel Prize awarded everywhere in physics, chemistry and medicine biology. Creative problem solving needs knowledge of basic sciences. An ordinary engineer usually knows about 100 effects, where there are about 10,000 effects in the scientific literature. Self-explanatory figure 5.19 to figure 5.21 explain the concept of scientific principles that can be used by the IPD engineers. Using a laser to measure the diameter of a micro-thin wire. The diameter of a hair or a thin string or electric wire can be measured by scattering laser light on the hair. The scattering creates a diffraction pattern consisting of a line of light and dark spots. Piezoelectric plates control gas flow. This apparatus consists of an elastic spacer such as silicon and two piezoelectric plates. The flexible spacer is positioned between the two piezoelectric plates. When an electric field is applied, the piezoelectric plates change dimensions. The change in the piezoelectric plates' volumes is proportional to the magnitude of the external electric field. The volume expansion of the piezoelectric plates compresses the spacer. the spacer blocks the gas passageway, the magnitude of the electric field is varied to change or restrict the gas flow rate. Electrical switching uses shape memory. A shape memory switch is used to break electrical contact. The switch includes a base, two connections, a resilient layer, and a shape memory conductor. The separate contacts are sandwiched between the bottom and the resilient layer. A conductor of shape memory material is pressed against the contacts by the resistance coating. The current flowing through the shape memory conductor creates heat. As the temperature of the shape memory conductor increases, it returns to its original uncompressed shape due to the shape memory effect. This breaks electrical contacts and the current ceases to flow. Thus, IPD engineer needs to keep close academic linkage with science researchers. Para 5.10.4 Separation Principles. The tool of separation principle is associated with physical contradiction. The real opposition refers to the design and development of a product which satisfies the contradiction of a physical parameter. The physical parameters can be expressed at hot versus cold, large versus small, yes versus no, soft versus hard, present versus absent. The physical parameters are difficult to express in numeric figures and hence more subjective. From figure 5.22 to figure 5.24 explains the idea of physical contradiction. The separation principles can be used by IPD engineers to overcome the physical contradiction. The separation principles are separation of contradictory properties in time, separation of opposite properties in space, system transformation, phase transformation or physical chemical transformations or substances. The reader may surf the net for the details about the separation principles. Para 5.11 Patent. The concept design of an innovative product is the intellectual property of IPD engineers. As in the case of physical property like house, cash, jewelry, intellectual property also needs protection. The intellectual property can be protected by a patent which can be defined in a simple term as a patent is a statutory right for an invention granted for a limited period to the patentee by the government in exchange of full disclosure of his invention for excluding others from making, using, selling, importing the patented product or process for producing that product for those purposes without his consent. The invention is defined in the Dictionary of the Patent Laws of India as an invention is patentable subject matter if it meets the following criteria. Number 1, it should be novel. Number 2, it should have an inventive steps or it must be non-obvious. Number 3, it should be capable of industrial application. The success of the product, which can be expressed by the financial outlay, will be in the hands of the person who may be other than IPD engineer who manufactures and market the product. The process of thinking and all other intellectual resources which are involved in getting the concept of design will be worthless for IPD engineer if the benefit to him or her is not received in terms of money. The IPD engineer therefore must know about the patenting, else his job will be worthless. The IPD engineer should also start the process of patenting along with the development of the concept of product. The process of patenting is explained in the chart shown in figure 5.25, which is self-explanatory. Following points must be kept in mind by IPD engineer while applying for the patent. Number 1, it is always safe to apply by filing provisional specification, that is idea or concept expressed in layman's language as early as possible. Number 2, no need of writing the claims in provisional specification application and it can be filed without anybody's assistance, that is online application. Number 3, a provisional specification is not mandatory. Number 4, complete specification involves the claims and it should be written with the help of patent attorney or lawyer. Number 5, the complete specification should be filed within 1 year from the date of filing of the provisional specification. Number 6, the complete specification is mandatory. The filing of the patent means submitting the application of complete specification to the patent office. Number 7, the examination of the patent will be done only if the request for the examination is made. Number 8, the patent will be granted once the examiner is satisfied. It is advisable to take the help of patent attorney or lawyer to defend the argument of the examiner. It may be noted that patent granted is different than patent filed. Number 9, it is advisable to file an international patent. And number 10, the annual fee of the patent to keep it live should be paid without fail. The reader is requested to visit the website www.patent.nic.in to get more information about the patent. Para 5.12 Rapid Prototyping. Rapid prototyping is introduced in Para 5.2 and Para 5.5 as an essential tool in product design and development. Para 5.12.1 CAD Model to Physical Model. Innovation is the buzzword in the technical world today, as the success of the industry is directly related to innovation carried out in process and product. It is rightly said that the need for innovation is for survival in the present turbulent technical world. Innovation in the product is more complex as the product meeting the need of customers is difficult to fabricate in the industry sector where profit motive and mass production are given top priority. Though the customized product is challenging to manufacture, it is possible to fabricate the product which satisfies the requirement of customers at large. It is also mandatory that the cost of the product is affordable to ensure the sale of the product. The design cycle for the design of the product is already shown in figure 5.3. Every stage of design, namely concept design, engineering design, that is use of design equation theory to get the value of the design parameter, detailed design, that is design analysis using FEM, experimental stress analysis, design optimization, is linked with the prototype. Prototype refers to the physical model of the product. Thus, prototyping at every stage of design helps the designer to finalize the design of the product quickly. The complete design of the product and also modification in the design can be carried out on a computer, but linking the design data or the CAD model to the physical model is most critical. The system which connects the CAD data to the machine that fabricates the physical model from the CAD data with minimum human intervention and tools is a rapid prototyping system. The design of the product is valid with the assistance of rapid prototyping system. The word rapid signifies without human intervention and tools, as the time required for decision making and operation of tools by humans is more, that is not rapid. It is thus possible to send the CAD data of the product at the end of the day to the RP machine and start the next day with physical product in hand. RP has revolutionized the technological world where innovation plays a vital role. One of the significant advantages of RP is to get whatever is possible on the computer in physical form. The design engineer is thus free to think and execute with no constraint from the manufacturing process. The design engineer is keen to innovate new products with the assistance of RP. The self-explanatory figure 5.26 shows the importance of RP in innovation, that is, design on a computer and gets its physical part instantly to know the feedback of customer. Para 5.12.2 Computer File Exchange. The computer-aided design engineer should learn the file exchange between the computer used for CAD and RP machine. The drawing format of the files in CAD is in DWG, IGS, PRT, ASM, etc. The RP machine accepts the STL format of the drawing file. It is thus necessary for CAD engineers to know the process of converting the drawing file to STL format. The STL format refers to standard tessellation language. It also refers to standard triangular language or stereolithography. The STL format converts the drawing entity into triangles. Para 5.12.2.1 Angle control and chord height in STL file. The angle control is defined as the angle made by the tangent to the side of the polygon, and the chord height is the distance between the side of a polygon and the farthest point on the curve. In figure 5.27 and 5.28, the concept of angle control and chord height is explained. Lesser the value of angle of control and chord height, more accurate representation of curve in STL files. It is thus essential to know the effect of angle of control and chord height on the number of triangles that can be formed. More the triangles, more perfect description of the model. Refer the table. Chord height is a more influencing parameter on the number of triangles formed. It is therefore desirable to keep the chord height to 0, that is minimum possible, while converting the drawing file to the STL file. Para 5.12.2.2 Stair-stepping effect. It is clear that the robust model, which is having non-linear or curved surfaces, is to be decomposed in terms of triangular facets in STL format. This may lead to a stair-stepping effect as shown in figure 5.29. The stair-stepping effect should be avoided as it is detrimental when the RP part is used in the manufacturing process directly, as in the case of mold preparation in sand casting. There are various ways to avoid this effect. The surface finishing using acetone vapor is mostly practiced in industry. Para 5.13 RP System Classification. The classification of the RP system is not unique and therefore difficult. Broadly, RP system can be classified as a liquid-based RP system, a solid-based RP system, or a powder-based RP system. Para 5.13.1 Liquid-based RP system. In liquid-based RP system, the physical part is produced by using the material in liquid form. Original materials in a liquid state are converted into solid state called curing. The heat source, such as ultraviolet laser, is chosen to control the curing. Types of liquid-based RP process. The stereolithography process is most popular. The self-explanatory figure 5.30 explains the process. It works on the principle of solidifying a photosensitive resin using a UV laser light layer by layer to develop the 3D object. The device consists of a platform that is moved down as each layer is formed in the tank containing the resin. The laser light is moved in the XY plane by the positioning system. Other liquid-based processes are mass-based process, inkjet-based liquid process, and rapid freeze prototyping process. Advantages of liquid-based process. Number 1. Because of high resolution and accuracy, the end product is a close physical model or prototype of the 3D drawing, allowing designers, engineers, manufacturers, sales and marketing managers, and prospective customers to handle the new product or prototype. Number 2. Design iteration can be made quickly and inexpensively, guaranteeing companies the best product possible in the shortest time. Process limitation of liquid-based RP process. Number 1. Parts with enclosed and hollow structures are a problem as the liquid may be trapped inside the enclosed body during building. Number 2. Unless the fluid can be drained during the process or somehow cleaned up after the build, it remains a process limitation. Number 3. Cost of the resin and the laser gun is high. Para 5.13.2 Solid-based RP system. Unlike a liquid-based process, which changes material from a liquid into solid state, solid-based process feeds material in solid form. Types of solid-based RP process. The extrusion-based process is most popular. It is also called as fused deposition modeling (FDM). Non-laser filament extrusion process that utilizes engineering thermoplastics which are heated from filament form and extruded in very fine layers to build each model from the bottom up. In the FDM process, ABS plastic is used as a raw material in the form of the filament. The thick, having more diameters, filament is extruded to thin, having lesser diameter filament, and part is developed by laying the thin filament layer by layer in a controlled temperature chamber. The filament is extruded at 270 degrees Celsius and part is developed in the chamber having temperature 70 degrees Celsius. There are two ABS materials required, one for the part, other for support. Refer figure 5.31, which is self-explanatory. Other solid-based processes are contour cutting and ultrasonic consolidation process. Advantages of solid-based process. Number 1. No exposure to toxic chemicals and non-laser based. A cost-effective process which uses ABS plastic and thus it can be run in an office environment. Number 2. It does not waste material. Limitation of solid-based process. Number 1. Due to nozzle diameter, accuracy can be limited compared to the liquid-based process. Number 2. The major problem includes limited materials, limited size and unpredictable shrinkage. Para 5.13.3 Powder-based RP system. The principle used is to fuse a powder material and deposit it on the required region. No supports are required since the powder bed supports overhangs and undercuts. Since the objects are sintered, they are porous. Selective laser sintering process (SLS) is the most popular process. The self-explanatory figure 5.32 shows the SLS process. Other powder-based processes are the 3D inkjet printing process, direct laser deposition, electron beam melting process, hybrid material and deposition, and removal process. Advantages of powder-based process. Number 1. The functional parts are possible to make. The process works with a variety of materials such as zinc, bronze, stainless steel, tool steel, etc. Number 2. The parts are created in an accurately controlled environment and thus the process provides excellent part stability. The fabricated parts exhibit a density very close to the theoretical one. Limitation of powder-based process. Number 1. The system is laser-based and mechanically more complex. Number 2. The system uses much higher energy to melt the powders and thus very expensive to operate and maintain. RP system can also be classified as a laser-based and non-laser-based system. The cost of a laser-based RP machine is more than a non-laser-based RP machine. The maintenance of laser and also the operation of the RP machine using a laser is complex. Hence, non-laser based RP machines are preferred to laser based RP machines in the manufacturing sector of a developing country. Para 5.14 Layer by layer RP process. To get the physical part, it is necessary to fuse the layers during the fabrication of the part. The layer thickness is significant in the RP part. It is clear that lesser the thickness of the layer, more accurate representation of the CAD part. In the STL file of part, layer thickness plays a significant role. The layer creation of CAD file and its role in the fabrication of the physical part on the machine is governed by the software which is customized for the machine. The build time for the part is inversely proportional to the layer thickness. The technician can handle the software operation. Every RP machine or process uses customized software suiting to that machine or process. The activity or methodology varies to some extent from machine to machine. It is possible to operate any software if the user develops expertise on any one machine. The software used on the FDM machine of the Stratasys is Catalyst. Some of the important operation of Catalyst software are explained in the form of a screenshot taken on the computer. Accurate physical parts can be fabricated on the RP machine if the CAD data is transferred to the machine using appropriate software. Software plays a significant role in getting the correct physical part. Para 5.15 Conclusion. Concept design, the first step in the design of an innovative product, is very crucial to IPD engineers. Well, beginning in the concept design is more than half done in product design and development. The subjectivity in concept design can be converted into objectivity if the techniques like bionics and trees are involved. As there is no set rule or algorithm for the concept of design, thinking plays the dominant role. The more and more exposure of IPD engineers to various fields and total dedication to the task of developing the innovative product will build the power of thinking and which makes the product sellable. Start early by converting the idea, that is virtual model, into physical model is the key to success in product development. The RP process is classified mainly in three classes, namely liquid based, powder based and solid based. It can be also classified as laser based or non-laser based. It is essential to understand that accurate physical part fabrication using RP is only possible if number 1, the CAD file is correctly converted to STL file. Number 2, the accurate data is transmitted from STL file to the RP machine using software. Questions. Number 1. Comment on the concept of an innovative product. Number 2. Comment. IPD engineer should study the techniques of trees and bionics to develop the concept of the innovative product. Number 3. Comment. The sale of the product is the last stage in product development. Number 4. Comment. 39 parameters in contradiction matrix cover each and everything required for product development. Number 5. How is the ideality useful in redesigning the existing product? Comment on the use of ideality in developing the product which does not exist. Number 6. Comment on rapid prototyping and its use in the design cycle. Number 7. Why marketing of product needs more attention to design engineer. Number 8. Compare the non-laser based RP system and laser based RP system. Number 9. List the RP process or machine and software used in the RP. Number 10. Arrange the group discussion in the class on the use of the RP system in developing countries in the areas other than engineering industry. Tutorials. Number 1. Consider screwdriver used in day-to-day practice. Improve the design of the screwdriver by using the ideality as the parameter. Number 2. Consider door opening as the task to be accomplished. Develop the product to open the door using the contradiction matrix and prove using ideality the superiority of your product over the existing product. Number 3. Change the layer thickness of the part and note the time required for the fabrication of part using FDM RP machine. Use software loaded on RP machine. Comment on your findings. Field study. Number 1. Develop the concept design of an innovative product as desired by you, which serves the need of the people at large. Fill the complete specification form of the patent office as a prerequisite for the patent. The product will be sold and marketed by your own company. Get the canvas of the business plan to become a job creator. Number 2. Visit the nearby industry and check how many industries are using the RP machine. Write the report indicating the feasibility of the RP process in the industries not having an RP machine. Write the specification of computers to be used for the suggested RP system.